All right, so hello everyone, and thank you for coming to my DS3 workshop this week. Today we will be taking a more interdisciplinary approach to data science than the previous quarter and go over how we can use data science skills to enhance the user experience. So before I get into what user experience is and the details of the workshop, I did want to introduce myself. So my name is Carolyn. I am a third year here at UCSD studying cognitive science with a specialization in design and interaction and minoring in data science. I am currently the design team lead for Savvy, which is a sustainable startup based in San Diego. And this upcoming summer, I will be working within the user experience department of List Reports, which is another startup, and actually where Peter, who's also here today, he's interning there right now for data science. So in the future, I am interested in kind of combining data science with user experience and potentially work in product management. And so as I just mentioned, I am currently working as a design team lead of Savvy. It's a sustainable startup founded by a UCSD alumni. And our goal at Savvy is basically to create a Chrome extension that rates clothing items on a scale of 1 to 10 based on a few factors so that customers or consumers, can better understand the environmental impacts of their purchases. So if you've ever heard of honey or used honey before, it's basically the same thing, but with like a small twist. We're focused on sustainability. So as the design team lead, some things I do include creating quarterly timelines and goals for our team to meet. I lead the design team meetings. I designed this logo right here. I did some design and front-end development of the Chrome extension MVP, which you can kind of see over here. And I communicate with all the other team leads as well as the CEO. This experience, as well as my previous internship experiences, really shaped my career trajectory. And so I found myself not so much gravitating towards data science, but the way it interacts with research and design. So enough about me. We can go ahead and start off with today's agenda. So first off, I do want to give a heads up and say that this workshop will be more like an informative presentation. So me speaking to you, this is mainly to give those with some knowledge of data science a little bit of background on how they can apply to the design realm, and also for those who have some knowledge in design but want to kind of intermingle that with some data science concepts. So we'll be going over the two disciplines, data science and user research, and how methods in data science and methods in UX relate to one another and enhance one another, and also a brief overview of a useful method used in data science known as A/B testing. So yeah, is anyone here familiar with UI/UX or data science? I don't want to assume that everyone knows about these fields, so I'll go over them a little bit briefly. So data science is an interdisciplinary field that combines domain expertise, computer science, mathematics, and statistics to extract meaningful insights from data. So some common roles you'll find in this field are data engineers, data scientists, data architects, machine learning engineers, and many more. And because this field is so interdisciplinary and it requires so many different skills and knowledge, it typically requires a lot of education and experience as well. So what that also means is that data science roles have a lot of strengths that can be applied to the user experience field. So as for user experience, on the other hand, it's also an interdisciplinary field, but there is more of an emphasis on the intersection of business, design, and technology. And the main goal of user experience is to design and develop products or services that are meaningful to its users. So if you think to Instagram or Facebook, for example, and how their interface is constantly changing, and have small adjustments here and there. This is all done by the different roles in the user experience team. So they base off these changes on both quantitative and qualitative data. And some common roles that you'll find in the user experience field include user interface designer. So they're the ones that give the product the look and the feel. There's the user experience designer, which are the ones optimizing the layout so that the product is pleasant to use. We got product designers, user experience researchers who obtain and interpret data, and there are so many other roles as well. So the two main roles I'm going to be talking about today include the data scientist and the quantitative user experience researcher. And so these two roles have a lot of overlapping skills, although their domain knowledge is very different. So when you combine these two roles and have them work together on the same team, it can provide optimal user experience. And you might even find yourself gravitating towards one role over the other. I know, like for me, myself personally, I thought I was really into the field of data science, but later realized that my skills and interests aligned more with the user researcher role. So both of these roles in the context of working in a company that is selling a product, they both work with data and are trying to gain valuable insights from them in order to improve the product. However, their focuses are pretty different, as you can see in this comparison chart. The data scientist is more interested in answering, how is the product performing? And how is it performing in terms of like the business side of things? And they base this off by collecting data about user actions or lack of action. They're using user signals such as the amount of views on a certain page, the click-through rates, the amount of time that's spent on a particular page, and so on. And because they are focused on the business side of things, or like improving the products in ways that increase the amount of engagement people have with it, they focus on prediction. And so their main source of data is big data, which includes log data. And big data isn't just having a large amount of data, but it also means that data is coming in and out at a very high velocity. So that means that data scientists work with a really big spreadsheets and CSV files with many rows and columns. On the other hand, the quantitative UX researcher is trying to answer a question of how do people interact with a product and how do they react to the product? In other words, they are more interested in measuring the quality of the experience users have when they interact with a product, and they want to learn how people are using the product as well as their intent with the product. And because quantitative UX researchers are more involved in representing the users as opposed to the business, they are focusing on inference. So they want to understand the underlying factors that affect the user's behavior when using that product. Also, another difference is that instead of working with big data, quantitative UX researchers work with thick data, and it's also known as little data. And this type of data comes from a variety of sources, including self-reported surveys, behavioral data, interviews, and occasionally log data as well. Thick or little data is not as large as big data, and it isn't coming in and out at a high velocity. So it doesn't cover as much breadth, but the upside to this is that their research contains a lot of depth. So you really get to understand the people using these products and their intentions behind everything. So this slide just goes over whatever I just said more in depth, and you can always go back to this slide when I post it later on. So the big question is, you have these two roles that seem so similar yet so different. So what happens if you put them together and their teams work together? So despite the differences between data science and UX research, there are many cases where these two roles fulfill the same tasks and goals. And these roles can also be very complementary to one another, offering a wide range of skills and backgrounds. In most companies, user researchers and data scientists work separately, but if they were to work together, they could provide a mix of both depth and breadth when it comes to getting insights from their products and users. So an example of how a company kind of uses this tactic, we have Spotify. So at Spotify, they believe in the approach that they need to use multiple complementary research methods um, in their everyday scheme of things. So their research team consists of both user researchers as well as data scientists. So at Spotify, the data scientists, on the one hand, are looking at the large scale overarching trends in user behavior and are employing methods such as A/B testing and statistical modeling. On the other hand, we have user researchers who are taking in information from interviews and surveys and really listen into what the users have to say and feel about their experiences and perceptions about Spotify. So now what? What's an example where a company actually benefited from having the data scientist and the user research work together? So I'm pretty sure we all know what LinkedIn is. It's a popular platform that connects recruiters with job seekers. So when you're scrolling through LinkedIn, you'll notice that there are people with profile pictures and people who don't have profile pictures. So the data scientists at LinkedIn conducted an A/B test, which I'll talk more about later, where they found that having a profile picture actually increases your odds of being reviewed by a recruiter. And this is a pretty cool insight, but that's all the A/B test can really tell you. It just tells you this, but not necessarily, the underlying factors, like why don't people have profile pictures? So in order for LinkedIn to really reach their goal of increasing the number of people who are using profile pictures, they have to understand why people don't. And once they understand that, they can better attack this problem and change the design, layout, or whatever they need to change so that they have more people posting their profile pictures. So the data scientists that conducted the A/B tests just assumed that the reason why people weren't posting their profile pictures was because they didn't understand how, or usability issues. They didn't know the way around the app and whatever. But user researchers were determined to really understand the underlying reason and not just assume that that was the reason why. And so after interviewing real people and real users of LinkedIn, they realized that that wasn't the reason at all. And the reasons why people didn't have profile pictures was because they either lacked confidence in their appearance, they didn't have a suitable photo to upload, they weren't sure what was appropriate to post as a profile picture, or some that just didn't want to subject themselves to bias, discrimination, or stalking. So this example of LinkedIn really shows us the benefits of having the data science team and the user experience team working together, because sometimes the two teams will produce conflicting results, but you really need to understand both sides in order to understand the bigger picture. So the results of this, it ultimately led to LinkedIn adopting the image preview feature, and this experience also changed the way they would approach designing this feature and design in general. And now they have the data scientists and the user researchers working together. So how can data science improve UX? So before we go into the last segment of the workshop about A/B testing, I wanted to explain where data scientists come in and improve the user experience. So the term UX design is a bit misleading because when people hear the word design, they ultimately think, oh, it's about making things look pretty. It's about art and creativity. But the design of interfaces is actually very technical and scientific. The designs that are made aren't based on your gut feeling or your intuition of what looks nice, but it's based on extensive research done by the research team. So decisions made within the UX team come from developing a hypothesis and running experiments, reviewing past reviews, and measuring and interpreting the results of the experiments that were ran. And it kind of sounds like a biology or chemistry lab, but instead of making a hypothesis about how different chemicals react to one another, it's about how different designs impact the user's engagement and their experience overall with the product. So data science can improve user experience by determining how different elements on a web page or interface are performing. And they can use that to boost conversions and optimize the average time people spend on the interfaces and products overall. And they can also obtain insight into the demographics, like who is using the product and how can we better cater towards them. So data scientists do all of this with a lot of different methods, which include A/B testing, heat map analysis, statistical modeling, and many more. So as for A/B testing, this last segment of the workshop, I'll be covering how it's implemented in the UX field. So as a disclaimer, what I'm covering today is pretty surface level. A/B testing requires a lot of coding if you're doing it the data science way. So I'm just going over the concepts, but if you do want to kind of go through how to do A/B testing in code, I linked an article in the later slides that will kind of walk you through an example. And if A/B testing is something that you would like to learn more about, specifically doing it in Python, we can definitely potentially have a workshop on just that in the near future. So I know that I've thrown around the term A/B testing here and there. And for those of you who are not familiar with this concept, you are basically testing a control group against a treatment group. So in UX, this would be testing your current design for a product or a interface or a web page and comparing that to a new design that you want to potentially use. And you want to see which is better to use based on a particular measured metric. And so this metric can honestly be anything, but it's most commonly the conversion rate or how long people stay on a page or the click-through rate. So what's going to happen is that you're going to split the traffic so that half of the people, roughly half, experience your version A or the control group, and half of the people are going to experience version B, the treatment group. And throughout time in your experiment, you are going to get results and identify which has the higher measured metric. And so some things that you can A/B test include the design and layout of a web page and how it affects the user's interaction. You can also test the order of different tabs or pages on the navigation bar. You can also test how effective two designs are at getting people to do something, so like a call to action. So for example, you want to test how a particular web page interacts with the user and how many people are going to do something. So how many people are going to sign up for a newsletter, or how many people are going to download a Chrome extension. And so for the example on the left-hand side over here, we have two different interfaces, and half of the people are experiencing version A and half of the people are experiencing version B. And After the experiment was over, it was found that version A had a conversion rate of 25%, whereas version B had a 5% conversion rate. And so because the measured metric here is the conversion rate, and version A got one that was much higher. In this case, we would say that the design from version A is better than the design from version B. So that's just like a really quick example of how A/B testing is implemented. So A/B testing is actually a really long process. Even though while explaining it, it sounds really short. But even before splitting the traffic and having people experience either version A or version B, you have to come up with a hypothesis and choose what your control group is and what your treatment group is. You also want to pick a sample size that is not too small and not too large. So the sample size would be the people that are going to be part of your experiment. So generally, having a larger sample size would give you more accurate results since it's more generalizable to the bigger population. And it's also easier to detect differences in the performance of the two different versions. However, due to time, money, effort, and whatever, you have limited resources. So it's difficult to really obtain these large samples that we want. So in the end, you just want to have a balance and make sure that you have enough people so that it's easier for you to claim the significance of one version over the other. So once you're done running the experiment, whether it's over a span of a week or 2 weeks or however long you make it, you are going to clean up the data, wrangle it, make it look nice so that we can perform methods on it, I guess. So you would do sampling, which is basically taking an X amount of data points from the bigger data set, and you're going to calculate the statistic that you're interested in. In this case, it would be the conversion rate. And you would just keep on doing this, sampling a small portion of the bigger population and calculating the statistic. And with that, you would visualize the results using like a histogram and compare that with the data point that you got from the actual experiment. Sorry if this is confusing. This is more for like something that is taught in statistics class. So this is just like a very brief overview. And so when you compare the actual result of your experiments with your sampling distribution, which is the histogram, if your data point is very far off or different from the sampling distribution, it means that you can assume that one version is better than the other. But if that data point is very similar to the sampling distribution, then you can't assume that one version is better than the other because it's the result wasn't unusual. So it's mostly due to chance. So once you figure that out, you basically conclude your result. So that would be, version A is better than version B, or version B is better than version A, or inconclusive. Yeah, so like I said at first, if you do want to go through an example through Python code, you can go click this link right here. And also we can always have another workshop in the future just on A/B testing in Python. So lastly, some tips for you when you go out and do A/B testing. You want to make sure that you don't bias your results. So it means that it's important for you to keep your feelings, emotions, intuitions, or gut feelings away from the experiment. Because in the end, the experiment will let you know the true results and the underlying behaviors of the users. Secondly, I mentioned before that it's good to split the traffic so that half of the people see version A and half of the people see version B. this is more so to get an accurate read of the population, because if you're going to have like 75% of people see version A and 25% of people see version B, the proportions are going to be different and it's hard to compare them very equally. So yeah, you want to balance and make sure around half of the people experience each of the different versions. And lastly, A/B testing is iterative, meaning that once you're done with one A/B test, it doesn't mean that it's over. Especially in the UX field, A/B testing happens back to back and continuously, because one test will only let you know the results about two different designs, whether one is better than the other. But in the design world, you're always constantly making changes to, improve the experience of the users. So once you run one A/B test and you find out which one has a higher success rate, that becomes the control group of your next experiment, and you test that against a new design that you have. And so this just keeps on going on and on as the designs change. So I know that was pretty brief, but that is all I have to cover for today. I want to thank you all for listening to my workshop, and I hope this gives you a bit of insight into how the data science and user experience fields intertwine with one another. Because when you combine them, you can have some pretty cool results. So Brendan asked, would you say data science and AI are the same or separate concepts? I would say they're pretty different. Data science is more involved in statistics, I would say, and getting insights from large data sets. Although AI and machine learning are definitely sometimes implemented within the data science field. Yeah. I'm actually not really familiar with AI, so I can't really say much. Yeah. So the majority of tech companies will have both data science and UX teams. They just work separately. So the data science teams will generally work to improve the business overall and make it so that their products increase revenue, whereas the user experience teams are more focused on bringing a better experience for the users. So yeah, it's not just Spotify. I would say the majority of tech companies have both. They just don't work together as often. Yes, so Peter clarified, data science and AI have some overlaps, but we can't say that they're the same or separate. That's a good point. Yeah. What inspired me to study data science? I came into college as a math econ major, and I realized that I was leaning more towards the analytical side of things. And one of my favorite subjects in high school was statistics. So that's why I decided to study data science and switch my major to that. But after another experience with a summer internship, I kind of shifted gears again, and data science is now my minor. So I still enjoy doing data science, but my main focus right now is design. Yeah. Are there any other questions? I'm gonna stop recording for now.